From homes to high-rise office towers, buildings now account for 1/3 of annual greenhouse gas emissions, and this trend isn't slowing down. To tackle this energy efficiency, researchers at the University of Chicago looked to chameleons for inspiration. They have designed a building material that changes its color based on the outside temperature. Their cladding would be lighter in summer to reflect heat and darker in winter to absorb heat. This could significantly reduce the energy footprint of air conditioning and heating. The property of a substance to change color with change in temperature is called thermochromism. In this video, we're going to discover how thermochromic building materials work and their pros and cons. We're also going to test out some pigments so you can make your own color-changing materials at home. Chameleons are one of the most fascinating reptiles. They are best known for their ability to change body color. Since they can't generate their own body heat, changing the color of their skin is a way to maintain a favorable body temperature. A cold chameleon may become dark to absorb more heat, whereas a hotter chameleon may turn pale to reflect the sun's heat. So how do they pull off these colorful changes? The outermost layer of a chameleon's skin is transparent. Beneath it are layers of specialized cells called chromatophores that are filled with sacs of different pigment. When a chameleon experiences a change in body temperature, its nervous system tells specific chromatophores to expand or contract, which changes the color of the cell. This allows them to produce a dazzling array of reds, pinks, yellows, blues, greens, and browns. Nature is truly incredible and inspiring. Humans have tried to replicate this phenomenon of changing colors by using liquid crystals and leucodyes. These pigments are used to make mood rings, coffee mugs that reveal text or images when hot liquid is poured into them, t-shirts, car paint, bathroom tiles, and toilet seats. Evan and Caitlin made a YouTube video on this a couple of years ago. It's a little bit disturbing, but also pretty funny. To test them for myself, I bought these two thermochromic pigments off Amazon. The one on the left changes color from red to yellow at 77 degrees Fahrenheit or 25 degrees Celsius. The one on the right changes from black to yellow at the same temperature. I mixed them with a 2-part epoxy and let it cure overnight. When heated with a hairdryer, you can see both the red and black pigments change to yellow. As soon as the heat source is taken away, the pigment drops below the critical temperature of 77 degrees Fahrenheit and they revert to their original colors, red and black. It sounds a bit magical, but there's some basic science behind the way thermochromic inks and pigments work. They contain 3 main components: a colorant, a weak acid, and a solvent. At lower temperatures, the solvent remains in a solid state, keeping the colorant and acid close together. As a result, these two pigments reflect light and look red or black. As the solvent warms, the colorant and the acid separate and there's no visible color, which exposes the underlying yellow color. These two pigments change color at 77 degrees Fahrenheit, but you can find pigments that are activated at a wide range of temperatures, from 5 to 140 degrees Fahrenheit or -15 to 60 degrees Celsius. I'll link them in the description if you want to test them out. I also use these pigments to make my own slime. The only ingredients you need for this experiment are Elmer's glue, thermochromic pigment, contact lens solution, and baking soda. I poured a bottle of Elmer's glue into a bowl and then added about half a tablespoon of baking soda to it, and then some red thermochromic pigment. I mixed it thoroughly but then decided to add a bit more pigment to it to deepen the red color of the mixture. Once it was ready, I slowly added 1 tablespoon of contact lens solution and continued mixing until slime began to form. Glue has long, flexible molecules of polyvinyl alcohol or PVA that slide past each other. Contact lens solution contains a small quantity of boric acid. Under the influence of baking soda or sodium bicarbonate, borate ions are formed. These ions help bind the long polymer molecules to each other so they cannot move and flow as easily. The red thermochromic pigment makes the slime change colors when the temperature rises. When it comes in contact with the heat from my hand, the color changes from red to yellow. The ability of materials to change color could help us reduce the energy footprint of buildings by reflecting heat in summer and absorbing heat in winter. However, if we use thermochromic pigments, we don't have much control over when the colors change. We are at the mercy of ambient temperatures, sunlight, and the weather. So, researchers at the University of Chicago have developed a new material that changes color with a tiny amount of electricity instead of heat. They call it an electrochromic building material. Their new non-flammable material consists of multiple layers, including a polyurethane film, a grid of gold wires, a layer of graphene and platinum, aqueous electrolyte, and a copper foil. In winter, the applied voltage pushes copper particles out of the electrolyte and to the platinum graphene film. They form a solid metal layer that reflects over 90% of internal infrared radiation. In summer, the voltage is reversed and copper particles dissolve back into the electrolyte. This creates a transparent plastic electrode that allows over 90% of internal infrared radiation to escape. The electricity used for inducing electrochromic changes in the material would be less than 0.2% of the total energy usage of the building. However, it could save up to 8.4% of the building's annual HVAC energy consumption. Now, I know what you're thinking. The astronomical cost of copper cladding is not going to be offset by an 8% reduction in energy consumption. There are other energy-efficient products on the market that are cheaper and more effective. That was my initial reaction as well, but I'm realizing that I need to tone down my cynicism and realism when approaching new tech. The building construction sector is highly varied. The more viable options we can provide designers and builders, the better. There are undoubtedly better solutions like passive house construction, continuous insulation, and high-performance HVAC systems. However, integrating thermochromic and electrochromic materials can complement and enhance those strategies. Before we discuss the other aspects of this technology, I'd like to introduce the sponsor of this portion of the video, Insulation for US. They are the largest US online retailer for insulation products. They ship nationwide with over 800 locations in their huge distribution network. Insulation for US is cheaper than big box retailers, and they offer a $60 flat shipping fee on 80% of all products. Brands such as Owens Corning, Rockwool, Hunter Panels, RMax, Kingspan, Handy Foam Spray Foam, Bubble Wrap, and more are available online to purchase today and to be delivered directly to your job site. Use promo code Belinda5 to receive an additional 5% discount off your next order with insulationforus.com. Now let's get back to the video. Another advantage of color-changing materials is their take on biomimicry. This is the concept of taking inspiration from nature to solve human problems. Unfortunately, a lot of biomimetic solutions are superficial. Designers use nature and sustainability to post-rationalize and justify outlandish parametric designs. But we'll save that rant for another video. I believe thermochromic and electrochromic products have a little more substance. We can be inspired by how chameleons control their body temperature, but at a certain point, we had to cut off those ties and make sure that these solutions are financially viable and effective. Only then will they be adopted by the masses. Let me know what you think about thermochromic and electrochromic materials and if we can use them to build better. Also, let me know if you're interested in more videos on biomimicry. I'll link these color-changing pigments in the description. I'll also link my Patreon page. I'm now offering early access to ad-free videos on Patreon as a thank you to everyone supporting me. Don't forget to hit the like button, subscribe button, and the notification bell too. Thanks for watching. See ya.